Okay, so what we're going to be working through is lesson 5. I teach this method of factoring last. This is the quickest method of factoring I find. You could write this at the top of your page or not. I'll just basically go through it. So the first method of factoring we did was GCF, right? After that, we did our PSA 1, PSA 2. Remember though that that's the informal wording. It's inspection or decomposition. What's important about these two methods of factoring is it will always be trinomials. So if I give you a trinomial, an x squared, an x, and then a constant, you say to yourself, is this a PSA 1 or is it a PSA 2? It's going to be one of the two. The last method of factoring, what we'll do today, it's something called difference of squares. You want to write this part down and you want to star this. How you're going to recognize that it's a difference of squares, it will always be two terms. Okay, so that's the first thing. Two terms. And the two terms must always be separated by a minus. So in between the two terms, there's going to be a minus. So separated by a minus. Okay, so let's look at an example of what is this difference of squares. Two terms separated by a minus. How do we factor this? Go down here to B, x squared minus 9. So you're going to look at this and you're going to say, two terms separated by a minus. I bet this is a difference of squares. When we talk about a difference of squares, you're going to factor it. You're going to have two answers. So you set up yourself two brackets. What you are going to do is both of these terms can actually be square rooted, okay? So if I said to you, what is the square root of x squared? That answer is x. So you're going to look at your x squared minus 9, and you're going to say, what is the square root of x squared? And that's x. You put an x at the beginning of each bracket. Then you're going to go to the 9, and you're going to say, what's the square root of 9? The square root of 9 is 3. What you have to put, though, the signs, one of these gets a plus, and one of these gets a minus. It doesn't matter which. So one gets a plus, and one gets a minus. I want to show you just off to the side here, so you have room to write. I want you to write these two factors, and I'm going to show you why one gets a plus and one gets a minus. So let's write off to the side x plus 3 and x minus 3. I'm just going to put my ones in. If I said to expand this, I want you to expand it. So circle that first term, get it distributed into the second bracket. 1x times 1x is 1x squared. 1x times negative 3 is minus 3x. You would then go to your plus 3, and you would distribute that into your second bracket. 3 times 1x is plus 3x. 3 times negative 3 is minus 9. Yes, what do you notice when you have a positive and a negative? What will happen here? It'll always cancel. If you put a positive and a negative, this will always cancel. Negative 3 plus 3 is gone, and you are left with 1x squared minus 9, which is exactly what we started with. So if you make the mistake of, let's say, putting x plus 3 and x plus 3, those middle terms will not cancel, right? So it always has to be one positive, one negative. Now, one more thing I want to show you before we quickly do the remaining ones. What is the square root of 1? Do you guys know? Square root of 1, you can take the square root of 1. Square root of 1 is 1, okay? So if I say like 1x squared and you're square rooting that, it would be 1x. So square root of 1 is 1. Okay, this one, two terms separated by a minus. Each of these terms could be square rooted. It is a difference of squares. You set up your two brackets, and you say, what is the square root of x squared? It's x. What is the square root of 49? It's 7. 1 gets a positive. I'll put it here this time. 1 gets a negative. You box it in, and you are done. Those are your two factors, 2 marks for that. This one. Okay, I'll do this one, and then I'll call 2 different people to give me the answers for this. So 2 terms, say to yourself, separated by a minus, it's going to be a difference of squares. Square root that, and square root this. Square root of x squared is x, it goes at the beginning. Square root of 36 is 6, it goes at the end of your bracket. And then it does not matter which one gets the plus and which one gets the minus. That would be your answer. Can you please do this one for me, number 4 and number 5? And then I'll just pick 2 people to read me the answers. Okay, Juan, what are you getting for x squared minus 1? What are the 2 factors? Okay, x minus 1. That's correct. Because the square root of x squared is x. The square root of 1 is 1. A squared minus 100. Ainsley, factor that for me. Perfect. Okay. Please write down underneath C, m squared minus n squared. 2 terms separated by a minus. Each of those terms can be square rooted. Shaywa, what would you get for the answer for this? Yep, m plus n, m minus n is correct. Because the square root of m squared is m. The square root of n squared is n. Okay, flip your page. And do these 4 for me. Yeah, the last one will get some of you. So for the last one, I'll ask to raise your hand instead of me picking somebody. Ethan, do you have the first one done? The a squared minus 4. What would the 2 factors of that be? Yep, a minus 2. Second one? Perfect, a plus 2. Next one, t squared minus 144. Caleb H, do you have that one done? Okay. Caleb B, do you have it done? This guy here. Yep, t minus 12, t plus 12. Okay, C, Jackson, do you have that one? And that's correct. And D. Does anybody want to do D? Raise your hand if you want to do that one. McLeet, tell me what you got for that. Yes. Okay, so this one is P plus 7 and P minus 7. I want to show you another way you could have done this, just in case you don't see this. Right off to the side, this is the same thing as P squared minus, what is 7 squared? 49, right? And if I said, well, factor that, you would say, okay, square root of P squared is P, square root of 49 is 7, 1 gets a plus, 1 gets a minus. And that's how you would do that. Flip your page. or if you're on a different page, this is making it more complex. Okay, so this is actually considered more complex than the last one, but it's exactly the same. Two terms separated by a minus. Actually, before we go through this, can you please scan those six? One of them cannot be factored. So scan them and raise your hand if you think you know which one cannot be factored. It's something you have to remember. Two terms. YE. Yes. It has to be separated by a minus. So this one is not factorable. If it had a GCF, you could take out the GCF, right? So if there was a GCF that you could divide out, you would factor it by GCF, but there's no GCF here, Ainsley. So one of your exam questions, it's going to be a multiple choice question, and it's going to be a difference of squares question. And the question is going to be, which of the following A, B, C, or D is not factorable? And the reason is it's testing that you know that um, difference of squares is two terms separated by a minus. Okay, because students that don't know that, they'd look at them and they'd say, well, this is factorable. I get a 2x here and a 5 here, right? So that's what it's testing, and that's exactly what the question would be. Which one is not factorable? Okay, A. I will do A, and you guys will do the rest. Set up your two brackets. You say to yourself, what is the square root of 16? And it's 4. What is the square root of t squared? T. Then you go on to the 49. What is the square root of 49? 7. One gets a positive, one gets a negative, and you're done. I'll pick somebody for B, C, D, and then you could raise your hand if you want to do F. Aiden, do you have B done? 9A plus 1, 9A minus 1. That is correct. Michaela, do you have C done? Perfect. Okay, for D, Shay, what do you have this one done? Yes. Anybody want to volunteer to do F? Raise your hand. Tristan, what do you got? Is he correct? Yeah. Because square root of 64 is 8. Square root of 9 is 3. Square root of A squared is A. Square root of B squared is B. Okay, I'm going to flip my page. Students will ask, can you make it harder than that? And the answer is sort of, but not really, because students tend to be really good with difference of squares. This question here is pretty much as hard as I could make it. Here's what happens. Students will look at A, and they'll say, two terms separated by a minus. Perfect. This is going to be a difference of squares. Then what they're going to try to do, so don't write this down, but they're going to try to do this. Then you're going to come into an issue, and the issue is, can you take the square root of 2? So square root of 2, you can't do. Same with the square root of 50, right? They're irrational numbers. So you say to yourself, okay, this is a difference of square question. You have to do something first before it becomes a difference of squares. Do you know what you have to do? What do you think, Jackson? GCF. So you say to yourself, I know it's a difference of squares, but I can't square root either the 2 or the 50. There's got to be a GCF, and the GCF is 2. Divide each term by your GCF. The answer goes in the bracket. So 2 divided by 2 is 1a squared minus 25. Then you look at that bracket and you say, can I take this bracket and further factor it? And the answer is yes. This bracket then becomes a difference of squares. So what you would do is you would bring down this 2, and then you would set yourself up 2 brackets, because you could square root that guy. Square root of 1a squared is 1a. And you could square root this guy. Square root of 25 is 5. One gets a plus and one gets a minus. So this question would be worth 3 marks, right? 1 for each factor. Whereas the other difference of squares that don't have GCFs, you get 2 marks for it. You cannot square root 3. You cannot square root 12. What do you want the GCF to be? 3. Let's get rid of that 3. Once you get rid of the 3, you're going to have 1x squared minus 4y squared. Look at that bracket and say, can I further factor it? You can. This guy would be a difference of squares. Square root and square root. Bring down the 3. Serena, what would you get each further factor to be? Nope. So, yep, you're close. Carly, do you know? Yep, what would these 2 factors be? Yes. The square root, you guys, of x squared is x. The square root of 4 is 2. And the square root of y squared is y. One gets a plus, one gets a minus. It does not matter which is which. And you could put the 1 in here or not. It's an invisible 1. We're going to do C last. I don't really like C because there's a bit of a hidden trick in there, and I don't usually like that. So let's do this guy. Be careful with your GCF here. Really look at it to see what you think the GCF is. Sean, any idea for GCF for this one? It's not just 3. It's 3x. Yep. X is common to both. You take out the x with the lowest power. Factor out that GCF, and you get 1x. 3 divided by 3 is 1. Subtract the powers, and you get 2 minus 27 divided by 3 is 9. You say to yourself, can I factor this by difference of squares? Yes, you can. So you'd bring down that 3x. And then what you would get here is 1x. Square root of 9 is 3, plus or minus. Let's look at C. I'm going to show you why I don't like C. So I wouldn't put C on a quiz, but you never know if you would see it like on a final exam, right? All of these questions we've been doing by GCF. So there's a GCF of this one. What's the GCF between 144 and 4? Yes, the GCF is 4. So let's GCF that out. Let's factor that out. So 144 divided by 4 is 36. And you're going to get p squared q squared minus 4 divided by 4 is 1. You would then look and you'd say, okay, 2 terms separated by a minus, factor that by difference of squares. Like this is Totally fine. You could factor that. So you bring down your 4, you set up your 2 brackets, square root this, and you square root that. And you're going to say, okay, square root of 36 is 6. Square root of p squared is p. And you're going to have a q. You're going to have a +1 and a -1. Everybody agrees? That's the answer for 3 marks, okay? I'm going to show you what a lot of you would do, though. And I would have probably done this as well if this was a test question. Can you rewrite this for me up here? A lot of students would look at that and they'd say difference of squares, right? And then they would say, can I square root 144? And you go to your calculator and you're going to type in square root of 144, and you can. And then you're going to look at the 4 and you're going to say, can I square root 4? And you can. So some students won't see that there's a GCF. So watch what happens if you don't see it. So do this question like up at the top. If you don't see the GCF, like the first time I did this question, I didn't see it because I know I could square root 144. I know I could square root 4. So then I said, okay, 12p, nope, what am I doing? Yeah, sorry, 12pq plus 2, and 1 gets a -2. Okay, what happens is when you factor, you have to what's called fully factor. So you have to look at this bracket and you cannot further, like you have to get to a point where you can't further factor the bracket. You can't take a GCF out. If you look at this bracket, could you take a GCF out? Yeah, what could you take out of this? 2. So watch what happens if you take out a 2. So you say, okay, I can actually further factor this bracket. You take out a 2, and then you'll get 6pq plus 1. And what can you do to this bracket? Take out a 2 again, right? So some students wouldn't see this. And you would get 6pq minus 1. And then what is 2 times 2? 4. 6pq plus 1, 6pq minus 1. And remember, that was the final answer. Like, that matches this. So all I'm saying is, if you initially did what I initially did, which was square root both of these, you're not wrong, right? This is correct, but it's not fully factored. You would then have to say, okay, 12 and a 2, I could take out a GCF. Here, I could take out a GCF. So for example, like if you ever got to this as a factor, and you said to me, Mrs. King, that's a factor, 5x plus 15, you would be wrong. You would not get that right. Because what could you factor out of this? A 5, right? So if you ever thought that that was a factor, you could further factor it. The 5 comes out, 1x plus 3, you cannot take a GCF out of this. So there's going to be a couple in your homework, and I'll show you which ones you have to look for the GCF. That is difference of squares. That's all there is. This is as hard as I could ask the questions. Here's what we're going to circle in your book. So open up to your homework. Circle number 2. I want you to do all of number 2. You'll get that done in under a minute. For number 4, what we're going to do before we circle them, can you please write which ones are not factorable? So don't shout it out because I want people to see if they could find them. There are going to be 2 in here that are not factorable by difference of squares. And there's no GCF. So Tristan, what's one of them? G, yes. This guy here, not factorable. Aaron, do you see the other one? O is correct. Okay, so those two we did. What I want you to do for number 4, I want you to write pick 8. Pick any 8. Some students will do them all, right, if they want more practice because it's so fast to do these, but I want you to pick 8. Okay, let's look at number 6. And for number 6, I actually want you to do them all, but we're going to star something. Okay, so I want you to do all of these. Students will look at C and they will say not factorable. It's not factorable by difference of squares, but what can you do here? If I gave you this, you could GCF it. So the GCF of this would be 3. You would divide out your 3, factor it out, and you would get t squared, which one am I at? P squared plus 9s squared. And then from here, are you able to further factor this by difference of squares? No, because this one has the plus. So what that means is you are done. That's all you could do for this question. Okay. For number 8, or sorry, for number 6 as well, what I want you to write, star this, all of these have a GCF. So you can't square root 8, right? They will all have a GCF. Okay, after number 6, 7, circle A to F. So 7A to F. And then number 12, I think it's a multiple choice. So do number 12, and I'll give you about 20 minutes. You'll finish this whole thing.